Hi guys, welcome to Ballistics. This is going to be a little bit of a longer PowerPoint today, a little bit of a longer recording, but I will try to get through it as quick as possible. Because there's two pieces to ballistics that we talk about. First, we talk about firearms, and we have to talk about gunshot residue. So two pieces. It's normally a 2-day PowerPoint and then the lab, but I'm going to do it in 1 day for you guys. All right, so first up, we have firearms identification. So firearms identification is an actual discipline of forensic science. I have friends that I graduated college with that are actual firearms examiners. So their job is to handle the identification of any firearm brought into the lab by a police officer. It's a discipline mainly concerned with the determining whether or not a bullet or a cartridge was fired from a particular weapon or not. Minute markings on the surfaces can partly individualize inanimate objects, especially those that are coming out of the firearm, and we'll talk about that why that is what it is. There are structural variations and irregularities caused by scratches, nicks, breaks, and wear that permit the criminalist and the firearms examiner to relate a bullet to a specific gun. Bullet and cartridge comparison. So the inner surface of the barrel leaves its markings on a bullet as it passes through it. That is particular. I don't know why that says peculiar. It is particular to each gun. Each gun manufacturer has its own unique interior of the barrel of the gun. You can see this one. It has a bunch of hills and valleys that twist in one direction. This one is twisting in another one, and the bullets it fired are representative of that. The gun barrel is produced from a solid bar of steel that has been hollowed out. It leaves behind microscopic irregularities and drill marks on the particular barrel that can impart to the uniqueness of one barrel from another from each manufacturer. Gun manufacturers do have to register their rifling process with the NRA. So the government agencies always know what manufacturer is using what particular degree of twist and landing groove number, but we'll get to that. The manufacturing of a barrel requires additional steps to impress its inner surface with grooves in a step that is called rifling. On the original surface, the bore is the difference between the grooves, and then the areas between the grooves are called, the raised pieces are called lands. Land groove is how I like to think of it. Land is always raised, grooves are sunken in. The benefit to rifling is to allow the bullet to spin faster and shoot straighter. Shotgun barrels are the only guns that do not contain rifling because when the shotgun pellet hits the end of the barrel, the goal is to have it pretty much explode and have a wide range of shot. As bullets are fired through the barrel, it engages the rifling of the grooves. The grooves slide the bullet through the barrel, giving it a rapid spin, allowing it to shoot straighter and further versus tumbling out of the end of the barrel once it hits it. Caliber is the diameter of the gun barrel, and it's measured between opposite lands. Recorded in 1/100th of an inch or in millimeters. So typically you hear like a 22 caliber, that would be a 0.22 of an inch, or a 9 millimeter. It's not an exact measurement of the diameter of the barrel, but however, it is just the distance between the lands. There are several different rifling methods. So before 1940, rifling by having one or two grooves at a time cut into the surface with a steel hook. The cutting tool was placed at the end of the barrel and slowly pulled through while the barrel was being rotated, or the tool was being rotated as it passed down the barrel. So the final result were grooves that spiraled either to the right or to the left. This method was developed into new technology needed to help increase the speed of weapons and create mass production. But this is originally how rifles would have been. Um, this is originally how rifles would have been manufactured to increase the speed of a bullet coming out of a gun. After 1940, we have several methods that are used today still in order to create the lands and grooves of a gun. The first is a broach cutter. It consists of a series of concentric rings. Each ring gets slightly larger than the preceding one, and it simultaneously cuts all the grooves into the barrel at a regular depth. It does get rotated as it's passed through the barrel, giving the grooves their desired direction and rate of twist. So you can see it here. This would be the broach cutter. Each of these rings gets slightly larger. It does get twisted by machine as it goes down the gun to create the rifling. Next, we have the button. The button press involves no actual cutting. The button is impressed with the desired number of lands and grooves and forced under high pressure through the barrel. A single pass of the button down the barrel compresses the metal to create the lands and grooves on the barrel's walls that are a negative form of the button. So think of like a stamp. It's pretty much how that works. And the most common method, because it is the fastest method, is actually the mandrel rifling hammer method. It involves no actual cutting of metal. It's a rod of hardened steel is machined, so its form is the reverse impression of the rifling it is intended to create. It is inserted into a slightly oversized bore. The barrel then is compressed with hammering or heavy rolling into the mandrel form. The mandrel gets popped out. The driver pushes the barrel out, and you end up with a gun barrel. This is the most common use because it's the fastest that a machine can do on its own. Because think of this as like a manufacturing line. So your driver pushes your barrel in, your mandrel goes in, push it through, it rolls, pops it out, the next one goes in. The rifling process does differ by manufacturer. Once the choice of rifling method is made, it's very rarely changed. Same with the direction, rate, and number of twists and number of landing grooves. So the numbers of lands and grooves, direction of twist, and rate of twist is very unique to most manufacturers. And like I said, this is kept on file with the government. This helps all government agencies from local to state to federal police officers with investigations to say, oh, this one has a 6 and 6 with a 40-degree to the right twist. They're able to track that down to a specific manufacturer. These are the class characteristics of a weapon's barrel that remain consistent. Plus, it's easier for manufacturers to say, oh, Smith & Wesson uses this, let's use this instead, which comes down to the sale, kind of the value of it at the end. Each gun, or each specific type of gun. So if we're looking at a Smith & Wesson revolver, each of those revolvers is going to have the same number of lands and grooves and have approximately the same width of the lands and grooves and direction and rate of twist. Obviously, in manufacturing, we know nothing's 100% perfect, so things will change, but this allows examiners to narrow down the manufacturer of the weapons just by searching those class characteristics, the numbers of lands and grooves, the approximate width and direction of twist. When you're comparing bullet markings, as a bullet is passed through the barrel, its surface gets impressed with the rifling impression and the markings of the barrel. So it emerges carrying the impression of the bore's interior surface. However, the grooves on the bullet are raised and the lands are sunken in because it's the reverse impression. So breaking down what this is really quick, we have first that groove is raised, the land is sunken in because it's the opposite of the gun barrel. But let's break down this. .22 is your caliber, so it would be .22 of an inch. So it's a .22 caliber. Winchester is the maker, the manufacturer, with 6 lands and grooves that are unequally spaced. So that is essentially what how this bullet would be classified. A .22 Winchester 6LG unequal. When comparing bullet markings, most examiners must, or all examiners must compare the bullets, the markings of a fired bullet to test bullets fired through the suspect barrel or very similar barrels for comparison. To prevent damage to the bullet itself, test firings normally take place into some type of recovery box. This one here is filled with cotton, but most commonly you see manufacturers or examiners firing into a bucket of ice cold water. It's called a water tank. Ice cold water, water slows the speed of the bullet, and 2, ice cold prevents it from being damaged. Same with the cotton. Cotton slows it down and preserves all of that material and prevents the bullet from being too cold. Most police officers have moved to the water tank because it's a little bit more easier to manage. When one of my friends started her career as a firearms examiner, you actually start as the bullet retriever. So someone fires the gun into the barrel. It sits for a few minutes. Sometimes they'll fire more than one round for comparison because you never want to just fire one and say it's a deal. You always want to have multiple points of comparison. After a few minutes, she would get her big magnetic rod and reach down to retrieve the bullets out of the bottom of the tank, clean them up, and deliver them for examination. Comparison, investigators are looking for the direction and rate of twist, the numbers of lands and grooves, and the caliber of the firearm. Differences in these class characteristics can result in elimination or inclusion from the investigation. If both bullets are similar, they are further examined for more comparison. Modern identification begins with the development and use of the comparison microscope. I really, really wish we were in school because I would have loved to have you guys play with the comparison microscope this year. Test and evident bullets are mounted and aligned in the same direction under the objective lens. Both bullets are observed simultaneously within the same field of view. This is the same microscope we would have used for hair and fiber, so it works just the same. The examiner rotates one bullet until a well-defined land or groove comes into view, and then twists the other one. So this is an actual microscopic comparison of 2 bullets. So here you can see it's a match, and then this here is no match. The comparison microscope, so once a striation mark has been located, the other bullet is rotated until a matching region is found. If no matching region is found, you move on to the next one. More than just the land and grooves do have to match. The longitudinal striations must coincide as well. These tend to be a little bit more unique to specific guns. The more they're fired, the more striations they're going to show. Once a matched region is found, the bullets are rotated together to continue to obtain additional matching areas. Firearms comparison, you need to really be in that 90th percentile of certainty. You need to be able to say, I am 90% sure that these 2 are a match. Anything below that really will not be taken too well by examiners and by the court system. Consideration and bullet comparison, you will rarely ever encounter a perfect match. Grit or rust can alter the markings, and most commonly when a bullet is fired and it hits a hard surface, it pretty much explodes and is not really usable anymore. Recovered evidence bullets can become so mutilated and distorted on impact, especially if they hit a very hard surface. Striation markings on the barrel are not always permanent structures and can change due to wear and tear. and often you receive a spent bullet without a suspected weapon. But don't panic if that last one happens. If it has not lost a lot of metal, we can do a weight comparison to determine the caliber. You can still count the measures of lands and grooves and determine the direction of twist, and use those class characteristics to compare to known gun manufacturers. Cartridge cases, so the act of pulling the trigger releases the weapon's firing pin, causing it to strike the primer, which ignites the powder. Firing a gun is a very complicated yet very simple chemical reaction. So basically, your firing pin strikes the primer under that pressure ignites, the powder ignites from the primer, that heat causes the bullet to fire out of the gun. Those gases generated by the burning gunpowder propel the bullet forward through the barrel, simultaneously pushing the cartridge case or shell backwards with the equal amount of force to something called the breech stock, which is the back of the gun before it is ejected out. The breech stock is the rear part of the firearm that can leave a dimple on the bullet or the shell casing. So here would be your firing pin. This dimple here would be from your breech stock. Looking at this piece of ammunition, we know that the manufacturer of it is Federal. It's a .45 caliber, and it's for an automatic weapon. That would be how you determine. Almost all manufacturers label the back of their cartridge cases in something similar to this. The breech block is also called the breech stock. It has a few different names. So when the firing pin is pressed into the relatively soft metal of the primer on the cartridge case, it reveals the minute distortions of the firing pin and the shape of the firing pin. These markings may be random enough to individualize a specific weapon. The cartridge case in its rearward thrust is impressed with the surface markings of the breech stock or breech block. The cartridge can leave other distinguishing marks caused by metal-to-metal contact or from the ejector or extractor. Imperfections on these tools cause markings to be formed on the cartridge case itself when it is leaving the firearm. In the absence of a suspected weapon, you want to look at the shape and size of the firing pin impression, the position of the ejector marks relative to the extractor. This can provide some clues to the type or make of weapon used in that specific crime. All right, gunpowder residues. Modern ammunition is a little bit different than older ammunition because we have found ways to make primers and gunpowder residue burn hotter, create a bigger chemical reaction, or leave less powder behind. So propelled forward toward a target by the expanding of gases created by the ignition of smokeless powder or nitrocellulose in the cartridge. Most powder does not always fully burn. Unburned particles and partially burned particles of gunpowder are propelled out the barrel of the gun as well as out the ejector towards the target. This is why people often have their hands swabbed if they're caught at a scene to make sure they were not the one that fired the gun. But gunpowder residue also goes out the barrel of the gun behind the bullet and can strike its target as well, which helps tell us a really good story. Distance determination. So the process of determining the distance at which a firearm was shot usually is based on the distribution of powder patterns and the spread of the shot. So here is a really good one for a handgun. You can see the closer the shot, the tighter and more gunpowder residue is versus the further away the shot is, the less gunpowder residue there is. Distance determination is necessary to determine the distance from which the weapon was fired, because this tells a very important story. Finding the approximate of where people were that were involved in the crime is necessary to establishing the facts of an incident. This way, Joe Schmo can't walk in and say, I was standing 3 feet away when he got shot, when the gunpowder residue says that he was standing point blank. The accuracy of determining distance varies according to the circumstances surrounding the crime. It is helpful when examiners cannot recover a weapon, because it still tells the story of how far away the weapon was fired from its original target. Handguns and rifles are treated the exact same way when it comes to gunpowder residue. The precise distance from a handgun or a rifle must be determined by comparing powder residue patterns on skin or clothing, and then doing test patterns at varying distances using the suspected weapon. White cloth or fabric, comparable to the fabric that the victim was wearing, is used as a test target if you are looking at someone who was shot. If you're looking at a gun was fired into, the ceiling, you're going to want to use the same material that ceiling was built out of. Due to the spread and density of residue patterns that vary by weapon, the comparison is only significant when it is made with the suspected weapon or a weapon of the same manufacturing. I'm talking year and everything, like that close. And it's only valuable when it's made with the suspected ammunition, or ammunition, if it's standard ammunition, that Federal 45 automatic, then you would want to use that. Comparing test and evidence patterns, examiners may find enough similarities in shape and density to include or exclude weapons or ammunition, but it's not always that simple. This leads to the judgment of distance from which the shot was fired. If you don't have the bullet, you're restricted to looking for recognizable characteristics around the bullet hole. The best approximations made as a result of general observations in the examiner's experience. The more experienced an examiner is, the faster that they can do this whole process. Closer to the target means you'll have more of a smoke-like vaporous lead halo around the bullet hole. Loose fibers around the contact hole can also show scorch marks from the flame discharged by the weapons. So that's very important, because it also tells a story about what the suspect was wearing or what the bullet may have passed through, because synthetic fibers melt, natural fibers singe. There is something called the blowback of the muzzle. This may produce a satellite or a star-shaped tear pattern around the hole. The hole of such is invariable, surrounded by the rim of smoke-like deposit of vaporous lead. So this is a good one. All of these are pretty good. These ones are showing a little bit more close range. This one's a good one too. Discharge patterns, so the halo of vaporous lead or smoke deposits around the bullet hole indicate a charge of about 12 to 18 inches or less. If you have a presence of scattered specks of unburned or partially burned gunpowder grains without any real soot halo, you can observe that at distances up to 25 inches, so just about 2 feet. Scattered gunpowder particles are noted at firing distances as far out as 3 feet or 36 inches. Ball powder ammunition can still be observed at inches at as close to 6 to 8 inches. Obviously, the closer you are, the more you have. And point blank is where you're going to get the most amount of ball powder ammunition. Point blank being like right up against. Weapons fired more than 3 feet from a target may not deposit any gunpowder residues on the target's surface. The only visual indication that a hole was made is by the dark ring of the singeing of the bullet passing through. That consists of a mixture of carbon, dirt, and lubricant, primer, and lead. These observations are general guidelines for estimating target distances. So just because these are estimates doesn't mean this is exactly what it is. You still need to do those test firings to figure it out. Shotguns are very different. Shotguns have their own rule of thumb that you can follow. Like I said earlier, shotguns are the only type of gun that do not have rifling because you don't want rifling with shotguns. Shotguns may also be related to test firings performed with a suspected weapon, using the same type of ammunition known to the crime. Every shotgun pellet comes with a different amount of little BBs inside of it, so it really depends on what you're looking for. But you can see here, this shotgun was fired at approximately 13 feet, where this one was fired at approximately 30 feet. In the absence of the weapon, muzzle to target distances can be estimated by measuring the spread of the distance shot. Close range shots varying in distances from 4 to 5 feet. The shot charge enters the target as a concentrated mass, producing a hole somewhat larger than the bore of the barrel. The general rule of thumb for a 12 gauge shotgun, which is your most common shotgun, is 1 inch of pattern is 1 yard of distance. There are other factors to consider when it comes to shotguns. You have to consider the length of the barrel, the size of the barrel, the quality of the pellets that were fired, the quality of the powder charge that was used, and the choke. The choke is the degree of restriction placed at the muzzle end of the barrel to help it either narrow or widen the shot. So if you're looking at a cylindrical bore with no choke, this is how wide you can get. But as you go to full choke, you narrow in your target more, which is going to change the 1 inch to 1 yard of distance rule. Gunpowder residue on garments. So all surfaces of all items must first be examined microscopically for gunpowder residue. This can be done through chemical tests or simple microscopic examination. You're looking for color, shape, and size of those gunpowder residue, and the chemical test determines whether or not it is in fact gunpowder residue that is present. Color, size, and shape are going to tell a story about who the manufacturer was, is it handmade, and everything like that. So that is firearms. Thank you guys for bearing with me. I know that was a longer PowerPoint than I normally post, but I really did want to get through ballistics for you guys today. Stay tuned because your lab is coming up and I really think you guys are going to enjoy it. As always, if you have any questions, just send me an email.